In this section, we're going to be talking about earthquakes and society. So, there's so many different types of hazards that are created when earthquakes occur. So, like older buildings that were not made for earthquakes, they can be brittle. This can cause them to collapse. It can cause them to crack, which is major structural damage, and it has to be repaired. A lot of times, you can't even repair some of this damage. You can also have the soil or the land shift so much that there is liquefaction or mudslides. Um, and another danger, of course, is tsunamis. But before we get to that, I wanted to show you a quick little animation from a school in Australia about what liquefaction is. Liquefaction is when the ground beneath you becomes like a liquid in how it moves, and it can basically swallow up the objects on top of it. Um, this reminds me of like something that I do with my foot when I go to the beach. When I go to the beach, I'll go and step um, near the water, right where the waves are coming up, and I'll kind of squish my foot into the sand. And the more I squish my foot into the sand, the more it gets covered up with sand until it's like you can sink almost your whole foot just kind of by wiggling it around in the wet sand. That's called liquefaction. I don't know if anybody else does that weird thing besides me, but I'll show you what that looks like here. So here they put like a little disc on some wet sand, and you can see that as the earthquake starts to shake, it just swallows up that disc whole. So it's sitting on it just fine. Um, and it's sitting on it just fine, but once it starts to just move with the earthquake, it just goes straight down. This is one of the reasons I used to live almost right on the San Andreas Fault in the desert, and in that area my house was completely on sand and almost completely on the San Andreas Fault. And this is one of the things that prompted me to move, um, just in case too much science gets in your head and you end up moving. So I want to show you some. So this has happened like liquefaction here, where this whole area has just collapsed because the ground has become liquefied. A tsunami is another huge danger of earthquakes. So a tsunami is caused by an ocean earthquake, and it causes the water to move up and down as it moves along, and it creates these very long wavelengths in the waves. So these waves can be, a meter tall out in the ocean, but they've got huge wavelengths. And when they start to hit the land, all this energy accumulates and it grows, and you can see it gets more shallow here, so there's less water but the same amount of energy, so these waves can get massive. In fact, they can get to 100 feet or more and have extremely fast like momentum. They can be moving very, very quickly. One of the worst tsunami of my lifetime has been the Indian Ocean tsunami on December 26, 2004. I had just had my first baby. I was up taking care of him in the middle of the night. I saw this come on in the news, and they said there was a very large tsunami that had hit Indonesia and Sumatra. And at first they said we expect that, maybe a few hundred people have passed away. And then through the night, as I took care of my baby, my new baby, and would maybe go to sleep for an hour or two and then wake up and then take care of him again, it got to where eventually, after a day or two, 230,000 people had died of this tsunami, and waves that were over 100 feet tall. I mean, just really catastrophic, very devastating and sad for this area. And there have been other tsunamis. in Japan. One, well, my nephew was actually living there, that just really can, just so much energy behind those waves that are caused out in the ocean, and more force than a normal wave. So, how can scientists help reduce the risk, the human risk of earthquakes? One of the things is they try to have earthquake forecasting. Um, so, uh, Scientists will study and determine the future earthquake probability by studying earthquake history and then measuring the amount of strain along the plates, and by measuring and charting seismic gaps. So let me show you a seismic gap. So this is a good picture. This is from Turkey. This is a piece of land, and it shows little, not little, these are big, but it shows points in time where different earthquakes occurred in this area and the points that they occurred. So you can see there was one in 1912, 1999, 67, 57, 44, 51, in 1943, 42, 39, and 92. So all these places have had different earthquakes where some of the pressure was released, and kind of a lot of pressure, because a lot of these were like 6 and 7s earthquakes. So those are significant earthquakes. But look at right here. This is something above the Marmara, I think it says, sea. And this sea above, like near Istanbul, has had a gap. It has not had an earthquake when all these other places have. The problem is that now scientists can see that this area of Istanbul and near this sea is much more likely to have an earthquake because it has a seismic gap, meaning there hasn't been an earthquake there in a long time since they've been recording this. So scientists use this to figure out, like in your area, what are the chances that a bigger earthquake will happen near you. Your book gives an example that um, in a certain place in California, scientists knew that every 22 years, that was the average, the area had about a 6.0 earthquake. So as time passed along, they knew that, they predicted that the earthquake would come. Now, the earthquake came about, almost 20 years late, like 17 years late, but it did have a magnitude 6 earthquake happen there. So yes, they don't know exactly when it's going to come, but they can start to predict, and they make these types of predictions to help save lives. So stress accumulation, the accumulation of stress, that means where it's not really letting stress off along the way, it's kind of saving up that stress. That's a bad thing with earthquakes. It's a bad thing with humans too, right? You should kind of let your stress off as you move along. So if the land is kind of letting off small bits of stress, like having small earthquakes as it moves along, it's not going to accumulate a lot of stress to have a giant movement and earthquake. So that's actually, having a lot of small earthquakes is actually a good thing in an earthquake prone area.